This tutorial is for 5th grade, Module 1, Lesson 3a. In this lesson, we're going to look at using exponents to write powers of 10. This chart is showing the patterns that you can see when we do use exponents. For example, if I'm looking at just the number 10, to express that as an exponent, I would write the base 10 again, and then I would write the little 1 up in the upper right-hand corner. So this exponent tells me that I just have 1 10. If I look at the next expression in the chart, I have 10 times 10. Since I'm taking 2 10s and multiplying them, I would express that as a base of 10 and an exponent of 2. So 10 to the second power is how I would read this exponent. And it means that I am multiplying 10 times 10. 10 times 10 is 100. So 10 to the second power equals 100. The next expression is 10 times 10 times 10. Since I'm taking 3 10s and multiplying them together, my base of 10 now has an exponent of 3. I would call that 10 to the third power. 10 to the third power equals 1,000 because 10 times 10 times 10 equals 1,000. The next expression is 10 times 10 times 10 times 10. This time I took 4 10s, multiplied them together, so I have a base of 10 and an exponent of 4. 10 to the fourth power equals 10,000. And that would continue as we keep adding more 10s to our expression. Now, a common mistake that is made is to look at the exponent as another factor. For example, if I look at 10 to the third power, well, we already saw that that means 10 times 10 times 10. The mistake that is often made is a student will take 10 times 3 to show 10 to the third power. Well, 10 times 3 equals 30. 10 to the third power equals 1,000. So you can see they do not mean the same thing. So we need to be careful and remember that we're not just taking 10 times the exponent. The exponent is telling me I need 3 10s that I will multiply together to get the answer of 1,000. It can be helpful to look at the pattern of zeros in our standard form to see how they relate to our exponents. For example, if I look at the standard form of 10, there is 1 0 in 10. The exponent is 10 to the first power. So it's to the first power and it's 1 0. In 100, I have 2 zeros. 10 to the second power gives me that answer with 2 zeros. 10 to the third power is 1,000. The number 1,000 has 3 zeros. 10 to the fourth power has 4 zeros. And so we can see that connection. So that's a good pattern to learn to help us remember the exponents to use when we're talking about powers of 10 or when our base is 10 each time. Now we can use those patterns to help us write these numbers in exponential form. The first problem is 10,000. So I need to write 10,000 as an exponent that has a base of 10. So I would start by writing my base. So I know it's going to be 10. And again, we looked at that pattern. So here I see 4 zeros. So my exponent is going to be 4. In other words, 10 times 10 times 10 times 10 is 10,000, or I could say it's also 10 to the fourth power. Going down, I have 1,000. Well, there are 3 zeros, so I know my base is 10, and the exponent is 3. 1,000 is the same thing as 10 times 10 times 10. In problem C, I have 100, so I have the base of 10, an exponent of 2. 10 times 10 is 100. On problem D, I have 10 times 100. Well, let's start by writing the product of 10 times 100. So 10 times 100 is 1,000. And here I have those 3 zeros. So I have a base of 10 and an exponent of 3. You could also see that in the problem, there are 3 zeros. So that's a direct connection to my exponent as well. So 10 times 100 is the same thing as 10 to the third power. In problem E, I simply have 10. So that's just 10 to the first power because there's only one 10 there. Problem F, I have 10 times 10. Well, 10 times 10 is 100. I've got those 2 zeros, so that would be 10 to the second power. Or again, the problem has 2 zeros, so that connects to my exponent as well. In this section, we'll use our knowledge of the exponents to do the multiplication. So first I have 9 times 10 to the third power. So I can think of 10 to the third power as 1,000. 10 times 10 times 10 is 1,000. So I'm going to take 9 times 1,000, which gives me a final product of 9,000. Down below, I have 9 times 10 to the fourth power. So 10 to the fourth power is 10,000. So 9 times 10,000 is 90,000. And again, you can see that pattern of zeros occurring in our answer, all connected to the exponents and the power of 10. Problem C, I have 4 times 10 to the third power. So we know that 10 to the third power is 1,000. So 4 times 10 to the third power is 4,000. And then 4 times 10 to the fourth power is the same as 4 times 10,000, which equals 40,000. Eventually, we would want the students to be able to skip this middle step here and just know that if I multiply 4 times 10 to the fourth power, I'm going to get an answer of 40,000. You can follow that pattern of zeros that we looked at earlier.